Hi everyone, thanks for tuning in. This is Nate, a Murf synthetic voice talking to you from GradientN. In this video we set up and train a fully connected voice classification neural net using the Audio MNIST dataset, downloaded from Kaggle. The link and reference are in the description box below. The Audio MNIST dataset contains samples of spoken digits 0 to 9 from 60 different speakers. We've renamed the files so that their names more clearly identified their speaker and number spoken. For example, file 10216.wave was renamed subject 02116.wave, indicating the 16th sample of speaker 2 saying the number 1. Also, we added a small number of files with just background noise to the dataset. We named the files with just background noise, silence. First, we'll select the sound files from the dataset and add them to the net. For our training set, we'll use the files for the first 10 speakers. NetDesigner gives us some data about the files and the file set, and shows a preview of the sound files. We're ready to design our neural net. We'll first pull out and drop an image input layer. Next, we'll select Net from the Tools window and click on the drawing area. In the Net dialog box, we'll turn off input and preprocess nodes. We'll set the number of layers to 2 and the hidden layer width to 9. And we'll set the number of output nodes to 11. We'll leave the activation functions as sigmoid, and then we'll click OK. We can then place the net where we like, and click on the drawing area to finish. We can use the auto router to finish up our connections. We just align the arrow in the direction of forward propagation and click the drawing area. We'll then select the hidden nodes and change their activation functions to tanh, leaving the activation functions of the output nodes as sigmoid. Then we'll select the Edit Process option and set the processes for our output nodes. When we highlight our output nodes, we make sure the Image Name Parser tab is selected, and then we select Digit Name 1 from the Image IDs list for our first output node. And then we continue selecting the remaining digits for the rest of the output nodes. The last thing we'll do before saving the net is to select the Train tab and click on the Validation option. We'll select the Validation Data Files option, and then select the directory for our validation files. Then we'll save our net, naming it Audio MNIST fully. We start training by clicking on the gears. We can reset the train graph y-axis, and then watch the net trained for a bit. We stop training when the net no longer appears to be improving. The net hasn't performed very well with the validation set, the red line on the graph, but has been able to learn the train data, the blue line, moderately well. We can also see that we've let the net train for about 2.5 hours. We'll open the output data window and save the data. We can view the net output file in Excel. At the top of the output file are train and validation classification matrices. We can see that we have a train accuracy of 74.9%, and that the net has done a moderate job selecting each digit. The net only has a validation accuracy of 11.2%, though. I suppose the results are to be expected. We are asking the fully connected net to memorize waveforms, which doesn't generalize very well to waveforms outside of the training set. For our next video, we'll add an FFT and a convolution to the net to see if we can improve validation performance. Thanks for watching. We'll see you next time.